Hey, Science Nines, Manchak here with another video lesson for you, which happens to be your last concept in Unit D, our electrical principles unit. So we are dealing with the last concept, which today is going to be all about electricity, society, and the environment. And what I'm going to do is just quickly go over here and just do a review of where we've been in the unit so far. So we started out the unit talking about static and current electricity. We talked about electrical safety, cells, and batteries. Then we transitioned into talking about controlling current, as well as measuring electricity and electrical circuits. Then we moved into talking about energy transformations, and electrical and mechanical energy. And after that, the last concept that we just did. Oh, remember in this D3 we talked about transforming electrical and mechanical energy using motors and generators. Now we're getting into talking. Our last concept we talked about measuring energy input and output as well as efficiency. And now finally we're doing our last one, which is electricity, society, and the environment. So we're going to try to take a lot of the stuff that we've talked about in this unit and bring it all together and talk a little bit or a lot about some practical applications for what we're doing with respect to electricity in our world. Now, I'm going to warn you that our textbook is a little bit out of date. And so a lot of the stuff that's in there, you might chuckle at and go, well, come on. I mean, that's stuff from, in the early 2000s, and that doesn't exist anymore, or it's changed or whatever. And you're absolutely right. That is the way it is. It's out to date. So what I'm going to try to do is update things a little bit as much as I can. And then we'll talk a little bit about how I'm going to have you guys take this a little bit further. So I'm hoping that this will be a relatively quick video lesson for you, and then you can jump right away into wrapping up this unit, which means we start Unit E next week, which is our very last unit on space and space technology and exploration and things like that, which I think is going to be a lot of fun for many of you. So what we're going to cover in this concept is we're going to go through some sources of electricity. Where do we get electricity from? I know we've talked a lot about electricity, and I think I've alluded to where we get electricity from a few times, but I don't think we've actually settled down and said, hey, my electricity comes from this source or from this source. We're going to get into that. We'll talk about sort of traditional sources of electricity, so coal generation, and maybe even sort of using burning natural gas, those kinds of things. And then we're going to get into some alternative forms of energy generation as well. That's going to then lead us into talking a little bit about renewable versus non-renewable resources and how all of those work and what we would classify as renewable and non-renewable. Then we're going to talk about the idea of sustainability, because we have to bring environment into the picture here. So how is our current regime, how is what we do with energy right now as far as electricity goes, how does that relate to the environment, and what's up with all of that? And then we'll talk about very briefly about some benefits and drawbacks of electrical technologies and how those technologies may have changed over time and what considerations we have to make with respect to that. Your textbook pages that you'll cover, and remember, all of this is just above where you found the link to this video. Your textbook pages you're going to use are these 15 pages here, 344 to 359. And then I've got what I think are some really good videos for you guys to watch this week. 3 relatively short ones. Will take less than 15 minutes of your time to watch them. I would strongly encourage you do it. This Electricity 101, or Energy 101, electricity generation is a really good introduction to how electricity is traditionally generated and then how we've moved on to some alternative sources. This one from National Geographic is all about looking at renewable energies, not only the benefits, but also some of the drawbacks that we should discuss with respect to that. And then this last piece here, I'm going to point it out. It has a little bit to do with what we're talking about in the content of this section, but I also think that I should point out that this is really important for the activity I'm going to ask you guys to do to wrap this unit up. And that's this activity here, switching electricity sources. I had another name for it. I'm still developing it as I do this video. But what that activity is going to have you do is go and explore how your electricity gets to your house and where it comes from. And then I'm going to have you go down a little bit of a rabbit hole and look at some alternative energy sources that might be available to you at your home, and how those might be, whether it's something that you could implement at your home and whether it be practical or not practical. So we're going to have you exploring that a little bit. And the purpose behind this activity is I'm going to ask everybody to do it, and then I'm going to use that activity as a bit of a rewrite. If you do really well on it, I can go and replace one of your marks somewhere else in this unit with the mark that you get on the activity. So a bit of incentive for you to ensure that you actually get the activity done, and we can use it to replace a mark elsewhere in the unit. You'll be wrapping up the worksheet you've been working on for the last couple of concepts. You'll have a practice quiz, as always, wait for feedback, and then a summative quiz. So I think that's enough of an introduction. Let's jump into this concept, please. So if you don't have your notes out already, please take them out, and we'll get started on concept D5, the last concept of Unit D. So these are the general outcomes or specific outcomes that we need to cover in this concept. So we're going to be looking at covering or identifying and evaluating sources of electrical energy, including gas, coal, biomass, wind, and solar. And I'm going to throw a couple other ones in there for you. Identifying means, remember, that we need to say, yeah, well, this is, this source of energy, or this is this source of energy, and this is where it comes from. And evaluating means you have to be able to tell me the good and the bad about it. Then we're going to describe the byproducts of electrical generation and how they impact the environment. So we'll look particularly at coal and gas and talk about the carbon dioxide that is produced by those processes and how that impacts the environment, and how maybe alternative energy sources will be better for the environment. We're going to identify examples of uses of electrical technologies and evaluate the technologies in terms of benefits and impacts. So that's going to come right at the end of the explanation. And then we'll talk about the conservation of energy resources and evaluating the means for improving sustainability. So we're really going to get into some discussion about green energy and renewable energy, and how it can be beneficial for us moving forward to combat climate change and other things that are going on with our environment. So let's get into 4.1 in your textbook. This is electrical energy sources and alternatives. So this is basically, where do we get our electrical energy from, and what are some alternatives to where we get it from. The burning of fossil fuels is where, especially here in Alberta, we get the majority of our electrical energy source, or is our electrical energy source. So usually what ends up happening is we know that fossil fuels are things like gasoline, coal, oil, natural gas, that were created from dead plants and animals buried for hundreds of millions of years and slowly transformed into these fossil fuels that we either mine out of the ground, like we do up with the oil sands, or we use a sort of oil drilling process or a natural gas drilling process to get them out of the ground. And then what we do is we burn them. So basically we ignite them in the presence of oxygen, and that generates enough heat to boil water. And then what we tend to do is we use the steam then to spin a turbine, which generates kinetic energy. So what we're talking about here is the typical energy generation process. So this has us looking back at D3 as well, remembering about generators, that a generator is a device that takes mechanical energy and turns it into electrical energy by spinning a coil inside of a magnet and causing a flow of electrons, and then we siphon that flow of electrons off. So fossil fuels get burned in a power station, and the chemical energy then is turned into heat. That heat energy, or thermal energy, is used to boil water to create steam. So the heat energy is transformed into kinetic energy, the energy of motion of those really hot water particles. Those really hot water particles spin the blades of a turbine, okay? And that turbine is part of the armature of a generator, okay? If you want to think of this kinetic here as mechanical energy, if it helps you out. And so we're using the steam to push the arms of that turbine, or the blades of that turbine, which spins the armature, which has the coil attached to it inside of the magnets, and as it spins, we generate electricity, electrical energy as our last. So we've got a bunch of conversions going on. We're going from chemical energy here with the fossil fuels to thermal energy here, which is kind of kinetic energy, to mechanical energy, ultimately to electrical energy. Okay, that's typically what we do. What we do to get the coal out of the ground so that we can burn it is we mine the coal, and we crush it into a powder, and then we blow it into a combustion chamber. Then it's ignited and burned to release heat. This heat boils the water, it superheats the steam to a high temperature, which spins our turbine. Okay, the turbine, we know, is attached to the large electromagnetic coil, which spins inside of a magnetic field, and we are basically operating a generator at that point. In a nuclear reactor, atoms of a heavy element, so we're going to switch gears for a second. A nuclear reactor, which I suppose could be considered an alternative form of energy because it's not combustion in this case. In a nuclear reactor, what we do is we take atoms of a heavy element, usually uranium, which is a very radioactive element, and we split them. Basically, we fire a slow-moving neutron at the uranium atom, and the uranium atom its nucleus is almost bursting with neutrons and protons. There's so many more neutrons in there than there should be. So firing another neutron into that nucleus destabilizes the nucleus, and it explodes apart. What we call nuclear fission, or the breaking apart of an atom. And in that breaking apart of an atom, we create two new atoms. And I believe it's barium and krypton, but I might be wrong. And in that process of breaking apart, a whole bunch of energy is released. That energy is used to boil water. That boiled water turns into steam. That steam spins a turbine. The turbine spins the armature of a generator, and we have the generation of electricity. A lot of these processes that we're going to see to generate electricity, it goes back to a generator, right? Taking an armature, spinning electromagnetic coil inside of a magnet, and generating a flow of electrons that way. Okay, so this is just a quick diagram to sort of illustrate what's going on in a coal situation. So we've got coal. We know that we crush it up into a powder. We put it inside the boiler. It burns. And then that creates heated water, steam at this point, which spins a turbine, which is attached, if we're looking straight onto this, that turbine is attached way down at the other end to the electromagnetic coil that's inside a magnet, and we get electricity that gets sent out to the grid. And then what happens is we have a cooling tower that cools down that superheated water and brings it back for recycling. Okay. There are coal generation plants all around Alberta that are still operating. There's at least one, maybe two still operating out near Wabamun. There's a big generation plant down near Hanna, whose name is escaping me off the top of my head. And there's others around the province. And if you ever get to go by them in the wintertime, the water that they release from the cooling tower usually goes back into a nearby lake or pond and then gets sucked back into the building. And you'll find in those areas that the water doesn't freeze in the wintertime. And that's because we're bringing that hot water into that area, and that area is not freezing completely because of the warm water. So that's how we typically generate electricity, by burning something or through nuclear fission, which is taking something like uranium and breaking it down into something smaller. What I'm going to do now is talk to you a little bit about other forms of heat that I would consider to be less traditional, so to speak. So heat from the Earth's core can also be used to generate electricity. And the third video that I mentioned in there in my introduction has the gentleman that's there actually at a geothermal generation site in Iceland, or was it Denmark? I believe it's Iceland, and he was exploring that site. And so we use geothermal energy, which is the heat from the Earth's core. And if that heat from the Earth's core, which is very hot, gets close to the surface, we can again use it to heat water to create steam. Run that steam through pipes to drive turbines connected to generators, which produce electricity. We can also do burning of some other sort by using biomass, which would be waste materials from living things. And so it could be everything from burning poop from living things, that's a possibility, to burning garbage, to burning brush, to burning all sorts of other kinds of things. So it's another type of fuel. It's produced. Often we take the biomass, the gas that's produced from the decomposition of garbage in landfills, and we can use that as a fuel to burn or to power a steam-driven generator. There's also waste heat from industrial processes that we might be able to actually use to produce steam. When we do these kinds of things, when we're using energy in one way and using waste energy to do something else for us, we call that process cogeneration. So we're doing something with it initially, and we're also generating electricity from a waste product. So that's a relatively good thing to do. What would normally have been wasted as energy, now we're using it to generate electricity for us. And so we've created less waste from that energy source to start with. So next thing we're moving on to, here's how we generate using water, okay? And water is going to operate off of the same principle. Approximately 20% of the world's electricity is generated using water. And all of that does is takes advantage of the fact that rivers flow. And so what happens is we have water higher up on a river and lower down on a river. And as it flows, it can spin a turbine, which is attached to a generator, which spins the electromagnet inside the magnetic field and generates a flow of electrons. And this takes advantage of something we call gravitational energy, or next year we'll call it gravitational potential energy. The water that's high up over here has more potential energy than the water down here. And so if we allow it to flow, it gradually loses potential and gains kinetic energy. Kinetic energy is the energy of motion. That kinetic energy will spin this turbine, which is attached to a generator, which is attached to power transmission lines, and then it runs out. What we do to generate high amounts of electrical energy from gravitational energy is we usually build a dam. And we build a dam in a river, which causes water to back up on the upstream side and to disappear from the downstream side to an extent. And then we can control at that point the amount of water that's going through to the turbines by these sluice gates. They can be open or closed, partially open, partially closed, allowing them to control the amount of water that we need moving through, which controls the amount of generation that we're doing. Obviously, the disadvantage of one of these dams is that it backs up water on the upstream side, and it can flood an area, and that's what happens when you build one of those dams. And it tends to reduce the flow downstream. Tends to, but not always, depending on the time of year. Okay, I hope that makes sense to you. So we can move on then to some other kinds of alternative energy sources. One of them is called tidal energy. We can actually take advantage of the tides to allow us to generate a flow or a movement of water that can pass over a turbine again, which will spin the armature of a generator and generate electrons. So tides, moving water, can power turbines, which then run generators. When the tide comes in, the water is trapped in large reservoirs and then allowed to slowly flow past turbines to release. So when the tide is coming in, we gather this water, and that pushes past a turbine. And when the tide is going out, we can slowly release it as well and gather energy. So there's another alternative source. And the great thing about tides is they happen on a very regular basis without us having to put in any extra bit of energy, without us having to burn anything that creates carbon dioxide in the atmosphere, those kinds of things. So an interesting way to do that. Wind energy is another one that is very, very common here, or becoming much more common here in Alberta. If you've driven down sort of in the area around Castor, sort of around Halkirk, that kind of area, Heisler. If you go through that area, there are a whole bunch of new wind turbines that have been put up. If you've been down to the area around Crow's Nest Pass, there's also lots of wind turbines there. Basically, they are these massive turbines that when the wind hits them, they start to spin. Okay, that spinning is mechanical energy. That and basically one of these giant things is a turbine again, which basically the turbine spins in the wind, which has a drivetrain which is attached to our generator. So it spins the armature of the generator, and we attach that to our power grid. And these things are designed to turn to face the wind so that they maximize the amount of wind that they're catching, so that they create a lot of electricity that way. There's a myth out there that they kill thousands of birds a year or hundreds of thousands of birds a year. If you want to dig into those myths, please do, because you'll find that actually cats probably kill, 100 or 1,000 times more birds a year than any wind turbine, maybe even more than 1,000 times more than any wind turbine might kill. So the science is a little bit wacky for the people that are saying wind turbines are murdering birds. And hey, I'm a bird guy, so I look into this stuff to make sure I know what I'm talking about. Other alternative energy sources. Now, solar energy, we have to be careful. This one does not involve a turbine in any way. Basically, a solar cell, which is one of those little black things on the diagram here. This is a solar panel, which has many cells on it. The solar cell basically takes the energy from the sun, the thermal energy from the sun, and it transforms it into a flow of electrons, what we call a photoelectric effect. Photo meaning light, electric meaning electricity. So the photoelectric effect is when we shine lights from the sun on these solar cells made from silicon. They create a little flow of electrons. We can harness, if we hook enough of them up together, we can harness a pretty decent amount of flow of electrons. A wonderful energy source, because other than in the manufacture of the solar cells, minimal input of fossil fuels or anything like that. And while they're operating, they're not doing anything to the environment. There's a myth out there as well that solar panels are absolutely useless in the wintertime. They're absolutely useless when it's cloudy out. All of that stuff is a myth. The only time a solar panel is not going to work effectively is when it's dark out. Okay, well, we can figure that out. We know when it's going to be dark, and we can use batteries to hold on to energy that we've harvested from the sun when it shines every single day. And we can hold it in batteries and release it in the evenings if we need to. We run our cabin, out north of Hinton in the woods, using those solar panel, a single solar panel to run a lot of the stuff that we have going on in the cabin. It runs great. The only time we worry is maybe when we've had several cloudy days in a row, because obviously when there's clouds, we don't charge as well as when there's not clouds. So think about that. Even when there's snow on the solar panel, the light energy still gets to the solar panel and we still get charging. It doesn't charge quite as well as we would have if it was completely clear, but that's easily solved by getting out with a broom and brushing off the solar panel. So there's a lot of misinformation out there that solar panels are useless here in Alberta, but Alberta is one of the sunniest places in the world. And you know what's great is that sun is very consistent. It comes up every day. And if it doesn't come up every day, we've got a really big problem on our hands. So that's a little bit more about alternative energy sources. I wanted to talk now just briefly about renewable and non-renewable energy with you. Coal is what we call a non-renewable resource, meaning that we have a finite amount of it, not an infinite, but a finite amount of it, meaning it cannot be replaced when it's all used up. And other fossil fuels are non-renewable as well. And I would argue that until we come up with nuclear fusion, nuclear is non-renewable as well, because the uranium that we use to run through nuclear fission is a finite resource, because we only have a certain amount here on Earth, and we could run out of these non-renewable resources. We do have several renewable resources that we've talked about. These can be replenished over and over again within a relatively quick time. So things like wind energy, right? Wind is there all the time, maybe not every single day, but in some parts of the world, it's very windy most of the time. Solar energy is there every single day. The tides come in and out daily. Biomass is there. We can grow things to be burnt, or use, whatever it might be, a landfill to siphon off gases from that. And the Earth's core is going to be there, warm and producing energy for a long period of time. And again, if it cools off, we may have bigger problems on our hands. So all of these things are renewable, which means that we can use them again and again and again, whereas a lot of our fossil fuels, or all of our fossil fuels, are non-renewable. We can't go and, we may have to wait hundreds of millions of years for more fossil fuels to be created if the conditions are right to create them. So just a note here on tree harvesting and replanting. This can also ensure wood supplies for energy can last indefinitely. If we manage forests effectively and ensure that we have adequate forests, then we can use that as a renewable resource as well. All right, so just a couple of points here really quickly on electricity and the environment. Then we'll get into the last section and we'll wrap this unit up. So every method of generating electricity affects the environment. Some create undesirable byproducts, such as we get fly ash from coal power plants, which becomes solids that float around in the atmosphere and create pollution. We get air pollution in the form of gases like sulfur dioxide, nitrogen oxides, and carbon dioxide. And if you think back to our previous unit, these should sound familiar to you as some of the pollutants that we worry about. Carbon dioxide thickens the atmosphere, quote unquote, enhancing the greenhouse effect. Sulfur and nitrogen oxides, they can react with water in the atmosphere to produce acid rain. They can contaminate the soil as we transport oil and gas. If we get leaks, we can damage the soil and need to reclaim it and treat it in a big way. And we're dealing with that in Alberta now with thousands of abandoned well sites that haven't been cleaned up by the companies that drilled them. We create warm water and steam in a coal plant, which needs to be cooled down in such a way. And if we're pumping that into a lake or a pond, we're changing the ecosystem. We're changing the environment of that pond. If we're doing nuclear power, we're creating radioactive waste. What do we do with the radioactive barium and krypton that we created, or radioactive uranium that we don't use? Do we put it underground? How do we seal it properly? How do we make sure that it doesn't damage the environment? And then we can produce other kinds of chemical pollution. And I'm not here telling you that the wind or water or solar power is absolutely perfect and there's nothing wrong with them. In the manufacturing process of those products, we're using fossil fuels often. Maybe we'll transition away from that use of fossil fuels. Some of the chemicals can be harmful to the environment if they're released into the environment. And then we have to be careful with what we do in construction of these massive sites. How is that going to alter the landscape, and can we do it in a responsible way? So we have to consider all of these kinds of things as we consider it from an environmental perspective. So we have to have a balancing act, and this is what this is all about. And this is the really challenging thing, I think, for you guys as we move forward in the world, is that we have to start to strike a balance right now. Right now, our carbon dioxide levels are rising to the point where we are seeing massive effects of climate change. And we're starting to see ocean acidification. We're starting to see more severe weather events. We're starting to see sea level rise. And all of these things are going to add up to big problems. So what we need to try to do is try to find this balance between ensuring that we've got, and it's not a sort of two thing balance. It's a balance between ensuring that the economy remains strong and that people can continue to be prosperous and live a comfortable life, we have to find a way to ensure that the environment is protected, because the environment is what supports us. It supplies us with clean air and clean water. It supplies us with food. It supplies us with entertainment and enjoyment. So we have to balance that in there. We have to balance in all of that what's best for society and everyone in general, not just what's best for one person or one group of people. So all of these things come down to personal and societal choices, environmental and economic choices, and what we have to do is try to find that balance, right? So suppose you want to conserve fossil fuels and reduce pollution. You consider maybe buying an electric car instead of buying one with a gasoline engine. What personal and societal considerations must you take into account, right? What are some things that we need to balance above and beyond what's going on with the environment, right? What's the engine efficiency? Maybe a little bit better with an electric car, or a lot better. What's the engine maintenance? That's a personal choice to make, but you know what? Hey, that engine maintenance on an electric car is a heck of a lot easier than it is on a gas car. And there's a lot less moving parts. Go look it up sometime. It's kind of interesting. How does it fit your lifestyle? Hey, electric cars don't go thousands of kilometers with, or 1,000 kilometers without needing to be charged. They need to be charged at some point. How is that going to fit with your lifestyle? What's it going to do with the local economy? Is there a thriving electric car population? Is that going to help support something local, or is there something else that's factoring in? Is this going to reduce or increase fossil fuel consumption, and how's that going to affect society and the environment? And what's the cost of the energy going to be in the long run? That affects society. That also affects you personally, right? So lots of decisions. It's a balancing act. None of these things are easy to decide. And so we need to take the time to consider them, though, and see what might be best for us personally, for society, for the environment, for economics, whatever it might be. It's all a big balancing act. It's not necessarily cut and dry. What this does lead me to talk about is something called sustainability. And sustainability is a big thing for me, and I want you guys to know what it means. It means using resources at a rate that can be maintained, and for me, this is the big one, that can be maintained indefinitely. That means, more, I'm not saying infinitely, but for a long period of time. Okay, that's what sustainability means. Can we maintain the use of the resources for a long period of time? If fossil fuels are finite, a non-renewable resource, can we maintain what we have so that everybody can use fossil fuels for an indefinite period of time? If sustainability is not achieved, future generations may not be able to support themselves. If we can't find a way to sustain what's going on economically, in society, or environmentally, then we may not be able to sustain future generations. And we need to consider what's happening today, what's happened in the past, but also what's going to happen in the future, hopefully a lot further down the road than just a 4-year election cycle. Sometimes a sustainable approach requires a different way of developing resources, or no longer using a non-renewable resource. And that is where society is shifting right now, and that's where our world is shifting, is we're realizing the impacts of burning fossil fuels on our climate, and the world is starting to shift away from the burning of fossil fuels. Cars are becoming more efficient. Electric cars are becoming more prevalent. People are moving to putting solar panels on their homes. And when I was in Hawaii last summer, it's ridiculous the amount of solar panels that people have out there. Sun shines a lot. Hey, that sun is free energy. As long as you put that solar panel up, you're going to generate electricity on it. If you're generating more electricity than you can use, you feed that into the grid and other people can use it. And most electric companies will pay you for that extra. So it's a really cool way to look at things. So sometimes we have to no longer use a non-renewable resource. Nobody in the world right now is saying we need to shut down the use of fossil fuels. However, there are a lot of people in the world saying, hey, we need to be more responsible with how we're using fossil fuels and slowly start to use them less so we can give the climate a chance to recover. That's what we're trying to say. So last thing I want to talk about really, really fast, electrical technology in society. I'm going to ask you to do some things here on your own. So I'd like you to read through page 354 of your textbook, and then list a few benefits of electrical technologies. Okay, look at what's in there. This is where I warned you at the beginning. This stuff is a little bit dated, meaning that, you know, you're going to look at these and go, yeah, really, a Discman? Yeah, I've never heard of that before, right? So think about that, but look at some of the benefits of them. Okay, take the time to do that, and then flip to the next page and look at some of the drawbacks. What are some of the drawbacks of electrical technologies that are out there? And then that's where we have to find that balance again, balancing the good with the bad. Okay, so this last little slide here is something that we've talked about lots of times, and is, you know, maybe less relevant right now, or maybe more relevant. But the transmission of electrical transmission of information. What we're talking about is what we use with cell phones, what we do with the internet, Wi-Fi, all of that kind of stuff. And there's concerns associated with that. You know, can we have access for everybody? And as we sit here in an isolation learning situation where I'm somewhere else and you guys are somewhere else, this access thing is top of mind for me. Do you have access? Can you get at this video that I'm putting for you up on YouTube? And does everybody have the computers and ability to do that? Privacy, making sure that you stay safe and that people can't steal your identity or steal important information and put it into the wrong hands. And then what can we do? How can we trust the information that's out there? And that's part of what I try to teach you in science, is to look at things from a scientific perspective, which means ask a question about it and then go and test to see if that question is true or not, and look at reliable sources to try to figure out your information. Anyway, just a couple of points there. What I wanted to wrap up with then is just a quick discussion here about where I want you to proceed for concept D5, the last concept in this unit. So go and have a look at the textbook questions that I posted up above where you got this link to this video, and do those. Then there is a worksheet that we've been sort of working our way through over the last 3 concepts. Wrap up any questions you haven't finished on worksheet number 3. And then I want you to do this activity. And I'm going to call it now, I think, evaluating an electricity source. So what we're going to do is I'm going to have you go and dig into how, first off, you get electricity in your house. So if you can figure out where your electricity comes from, maybe you need to look up the company that delivers electricity to your house via the power lines and see where they get their electricity from. Is it mostly coal generation? Are they using some wind power, solar power, whatever it might be? Go and do that exploration. Okay. Then the next thing you're going to have to do is you're going to do research some alternative energies that are available for us here in Alberta. Okay, so what sort of alternative electricity sources might be out there for you? How could you get a hold of that kind of stuff? Then I want you to do is pick one of those and make that, do some more research on that specific one and decide if basically it's something that could be done in your house. Is it something that you could use? So I want you to evaluate how good it is from your context, from your perspective. So I'm going to have you looking at things like cost. I'm looking at my notes down here. I'm going to have you looking at things like practicality. Is it practical to put a big wind turbine in your backyard? Or could you do 2 smaller ones? Or how is it going to, what is it going to look like putting solar panels on your roof, right? Think about that. Think about the environmental impact and the sustainability impacts that are associated with that. And then the last question that I'm going to ask you in that activity is basically, would you switch to this energy source, and defend your answer? Why or why not? Then I'm going to look at what you've done for that activity, and I'm going to give you a mark on that, and whether we use that or mark is up to you or not. But you could use it as a possible rewrite for a concept in this unit, if you choose to do so, and you work hard on it and you're proud of what you've done, or we can just leave it there as a mark, as a formative mark, so to speak. Doesn't count for your final mark. So I think that's about it. After you've done the activity, then go ahead and do the practice quiz. Once you're done the practice quiz, as always, wait for feedback, and then I will give you the go ahead to do the summative quiz if I think you're ready. So that's it. Unit D, finished, done, and out of the way. That's an entire unit taught in isolation learning. Thank you for sticking with me for the last 40 minutes through this lesson that I thought would be a lot shorter, but hey, I talk a lot. And we will see you then soon in Unit E. next week. And stay safe until then, and we will talk soon.